Hello, and welcome to Module 8.1a, Multiplication Properties of Exponents. And today we're going to focus on the product rule. Our objective for the day is that I can find products of monomials. Now, let's just start off with what does that word mean, monomial? A monomial is going to be a number, variable, or product of a number and one or more variables. So examples of a monomial could include, 7x. It could be 3xy. It could be 5x squared, right? It could just be a 4. These are all considered monomials. It could just be an x, right? So it's a number, a variable, or the product of a number and one or more variables. Now, we have exponent, base, and power. So a power is going to be the entire thing that we're going to talk about. So we're going to have x and we're going to have a 5. So a power is the whole thing. Okay, a power is the base and the exponent together. The exponent is the small number that shows how many times the base is being multiplied. And it's that number right there. The base is the number or variable being multiplied by itself, and it's that. So a power is the entire thing. The exponent is that small number that is in the superscript, it is above, and that's telling us how many times the base, the smaller, or the big number down below, or the big variable below, how many times that thing is being multiplied by itself. So we have a couple forms here that we're just going to go through what are the basics of this. So exponential form is writing it as an exponent. It is a base and it is a exponent, right? Expanded form, we are going to spread out all of this multiplication. So in the first case, we have 4 to the 5th power. So that means that exponent of 5, right? We say to the 5th power, that's, to the exponent of 5. We're saying we're taking 4 and multiplying it by itself 5 times. So exponents are shortcuts on multiplication. So it's going to be 4. It would help if I'm on a pen instead of a marker highlighter. So we have 4 times 4, that's 2, times 4 is 3, times 4 is 4, times 4 is 5. Right? So there are 5 4s there, right? Exponent is 5, the base is 4. There are 5 4s being multiplied. Standard form is when you actually do the multiplication on it. 4 times 4 times 4 times 4, and you're going to get 1024. Now, if we look at the second line in this table, we have a group of 5s that are outlined for us. We have 1, 2, 3, 4, 5, 6, 7, 8. So the number that's being multiplied is 5, and there are 8 of them. So it is 5 to the 8th power. So then when we multiply that all out, you're going to need a calculator on that. I'm not going to expect you to do that in your head. You're going to get 390,625. So 390,625. Now, 16. There are 2 different ways that we could get to 16, right? When we think about what are our numbers that we can multiply by themselves to get to 16. Well, the one that comes up, off the top of my head would be 4 times 4, which would be 4 to the 2nd power. Pretty easy, right? Well, but then I did say there's another way of doing this, and well, 4 times 4, well, what makes up 4? 4 is just 2 times 2. So if I did 2 times 2 times 2 times 2, that also gets me to 16. So that would be 2 to the 4th power. That would also get me to 16. So both of those would be an appropriate exponential and expanded form for the standard form of 16. All right. So let's take a look at what is this product rule. When multiplying powers with the same base, exponents are added. So our example is a to the m times a to the n is equal to the a to the m plus n. So if I focus in on these first four, first box of four, so we've got 12 is our base. Both of those are the same base, and it's 5 plus 3. 5 plus 3 is 8. Okay, so that's 12 to the 8th power. Now let's look at letter B, and I'm going to work it in a slightly different way. I'm going to convert these, instead of doing just the rule of you add the two exponents together, let's kind of explain and see why does it work that we can just add the two exponents together. So my first term is x to the fourth, which means if I put it in an expanded form, it's 1, 2, 3, 4 x's. And I'm being multiplied by x squared, which is 2 more x's. Well, when I add those together, how many total x's do I have there? I have 6 x's. So it's x to the 6th power, right? That is the same as doing 4 plus 2. 4 plus 2 is 6, right? We're saying we have 4 in the first segment, there's 2 in the second segment. How many total do we have? We have 6. All right, since it's on the screen, let's take a look at E and F. Letter E, we've got a fraction inside of parentheses. That's kind of weird. We're going to just roll with it, and we're going to keep it the same. We're going to keep the same parentheses, right? And we're going to have 1/3, if it'll let me write. We have 1/3 in parentheses, and we have 3 plus 7 as our exponent. So that's going to be 1/3 to the 10th power. And I'm not going to ask you to actually multiply this out yet. We are going to talk about that in an upcoming lesson. But right now, we're just figuring out what are these base exponents. So y to the 1/4, y to the 5/4. Okay, this is kind of weird. We're not going to be able to do the expanded form because reasons. We'll talk about that in a future lesson when we start talking about radicals, because each one of these actually corresponds to a radical. But we're going to talk about that in a completely separate lesson. All you need to know is that you can treat this the same way. A fractional exponent can be treated the exact same way that a coefficient exponent would be, an integer exponent would be. So y to the 1/4, y to the 5/4, we're going to add those together, and we get y to the 1/4 plus 5/4, which is y to the 6/4. And if I remember anything about my expectations in algebra, it is that we need to simplify fractions whenever we see them. So it's y to the 3/2. Okay, y to the 3/2. All right, now let's take a look at the other four that are in our example here. Letter C, we're going with the fact that we have a decimal. Again, decimal doesn't matter. We're going to focus in on the fact that it is the same base. The decimal is the same at 0.6 in both of these terms. And we are going to just add the exponents. So you have 0.6 inside of the parentheses. You have 4 plus 2 outside of the parentheses. Our result is 0.6 to the 6th power. Letter D. Okay, this is the first time we have a negative exponent coming up. We're going to explain more about negative exponents in lesson 8.3, but for right now, all you need to know is you are going to treat it exactly the same as the positive integers that we've already seen. So you're going to keep the base, which is 8, and we're going to add our exponents together, -3 plus 6. And we get 8 to the 3rd power. -3 plus 6 is a positive 3. All right, now let's look at letter G. Letter G, we have 6 and 6 to the 5th. Well, okay, this is weird. 6, that doesn't seem to have an exponent on it as, face value. But just like, when we were doing exponents, or sorry, when we were working with variables and there's no coefficient in front of the variable, we assume it's to be 1. Just like in science class, if there's no coefficient in front of a chemical, we assume it's 1. If there's no subscript of 1, no subscript at all, we assume it to be 1. If there's no exponent shown, we assume that it's going to be 1. So now we've got 6 is our base, and we have 1 plus 5, and that's going to give us a 6 to the 6th power, right? So we had 1 6 and 5 6. There are now 6 total 6s. All right, and letter H, kind of straightforward. We have z to the third, z to the second. We could say z cubed and z squared. Cubed is the word we use to apply to 3, an exponent of 3, and squared is the word for an exponent of 2. Anything beyond 3, we just say to the 4th power, to the 5th power, to the 12th power, whatever it may be. All right, so we have our base, z. We do 3 plus 2. We've got z to the 5th power. And we're going to zoom out now because there are 4 you-try problems that I want you doing on your own. Go ahead and get started on them, and then we'll go over them as a group. So as I look at letter I, we've got the parentheses. Anytime you have parentheses in an expression, it's probably wise to keep them. So we have -4, and we have an exponent of 2, and we have an exponent of 5. And so that's -4 to the 7th power. 5 plus 2 is 7. Letter J, we've got y to the 9th, y to the 12th. That comes to y to the 9 plus 12, which simplifies to y to the 21st power. All right. K and L. K, we've got -1/3 and 5/3 as our two exponents. So we have -1/3. We have plus 5/3. That gives us x to the 4/3 power. And letter I, we have 1.2 to the 5th power plus a -3rd power. So we get 1.2 to the 2nd power. 5 minus 3 is going to give us 2. All right, so now we're going to flip over to the next page, and we are going to continue with example 1. And now we're going to start adding in multiple pieces to this. So now our monomials are not just one coefficient or one variable term. Now it's going to be combinations of coefficients and variables. So the first thing that you want to do, you're going to group the coefficients and the variables together, right? If we go back to our rules, so this is our multiplication properties, and this is the associative property, or commutative property rather, where the order of the multiplication doesn't matter. So 4 times x cubed times 6 times x to the 5th, that order doesn't have to be in that order just because they're all being multiplied. So we can group our coefficients together, and we can group our variables together. So the first thing I'm going to do is group the coefficients. So we have a 4 and we have a 6, right? So we're going to just kind of mark those off that we've dealt with those, right? And so now we have x to the 3rd and we have x to the 5th. Okay, so now we're going to use the product of power rules to simplify what we have here, now that we've rearranged it. So the first thing we do are coefficients, right? We're going to do numbers first. 4 times 6 gives me 24. And then we have x to the 3rd times x to the 5th. So that's x to the 3 plus 5, right? Our base is the same. We're going to add the exponents. And when we simplify that, we get 24x to the 8th power. Now it's important to note here, right? When we look at our exponents, the exponent is only associated to what it's on, right? So that 3 is only on the x, the 5 is only on the x, right? Each term is looked at separately, right? Each coefficient, each variable is looked at separately. And so the variable on the 4 is a 1. Sorry, the exponent on the 4 is a 1. The exponent on the 6 is a 1. Right? So this is an important distinction. So if, like in science class, when we were looking at chemical equations, right? Parentheses means we distribute. No parentheses means it's only on that specific element when we're talking about subscripts, right? We're doing the same thing here. If there are no parentheses, then it only applies to what it is on. The exponent only applies to the term that it is on. All right, so let's look at letter B. We've got 5x times x to the fifth times 3x squared. So we're going to start with grouping our pieces together, right? Numbers first, letters second. So we have 5 times 3, right? So that took care of those two. And we've got an x to the fifth, and an x to the second, right? And that x, let's remember, is x to the first power. And I'm going to just write that 1 in right now so that I get in the habit of thinking about it as being an exponent of 1. So let's start. We do our multiplication. We've got 5 times 3 is 15. And then we've got our base, and we're going to add our 3 exponents together. So it's 1 plus 5 plus 2. And we get our 15, our base of x, 1 plus 5 plus 2. 5 plus 1 is 6, plus 2 is 8. So we have 15x to the 8th power. All right, so let's look at letters C and D then. So again, our first step we want to do is group our coefficients together, and we're going to group our variables together. We have 3/5 c to the 3/5 times c to the 3/5. All right, 2 times 2 is going to give me 4. And I'm going to have my base c. We have 3/5 plus 3/5. Base stays, or the coefficient out front stays the same. The base, and now 3/5 plus 3/5 is 6/5. All right. Letter D. Again, let's group our coefficients first. So we have 3 times 2 times x to the fourth times x to the fifth. So now that we've grouped them, we do the multiplication. 3 times 2 is 6. We have x to the fourth plus fifth. So we get 6 times x to the 9th power. Okay. All right, let's look at letters E and F. Letter E, we've got negative 3y cubed times 2y to the negative second times y to the first. We actually wrote in y to the first there for some reason. All right, process is exactly the same. We group our coefficients together. So we have negative 3 and we have 2. We group our variables together. Y to the third, y to the negative second, and y to the first. So my next step, do the math. Negative 3 times 2, negative 6. And we've got y to the third plus negative second plus first. So when we do the math on this, negative 6y. So we've got 3 plus negative 2 plus 1 is going to be a 2, positive 2. Right, so negative 6y squared. Okay, letter F. We have 6y to the 9th times negative 1y to the second times 5y to the negative 4th. Okay, let's group all of our coefficients together. So coefficient, we have a 6 times a negative 1 times a 5. And then we group our variables together. We have y to the 9th times y squared times y to the negative 4th. Do the math first on your coefficients. 6 times negative 1 times 5 gives you negative 30. Y to the 9th, so now we've got our y's. We've got 9 plus 2 plus negative 4. So we get negative 30, y to the 9, 10, 11, 9, 8, 7, y to the 7th power. So negative 30, y to the 7th power. Okay, now we're going to look at letters G and H. Letter G. We've got j to the second, k to the fourth, 3j to the third. So let's group everything together the way we need to. So we start with our coefficients in front. The only coefficient we have is a 3. Next, we start with our variables. We've got a j squared, and we've got a j to the third, and then we have our k variable to the fourth, right? So we're grouping one variable at a time because we can't combine j's and k's because those are two different things. One's a j, one's a k. They're different bases, so we can't combine them. So everything has to have the same base. All right, so the 3 out in front just stays the 3 out in front. We have a j to the 2 plus 3, and we have a k to the fourth. So the 3 stays the same, k to the fourth stays the same, and we do j, if my pen will cooperate. So we have j to the 2 plus 3 is 5. So it's 3j to the fifth, k to the fourth. All right, letter H looks a little bit weird because we've got parentheses here, but everything's being multiplied. So essentially, our parentheses go away. Right? This is the associative property. So the parentheses all go away. And now we've got b to the 2/3, c to the 2/5, b to the 4/9, c to the 9/10. Whoa. Okay. There's a whole lot to unpack here. So let's just start with grouping everything together. So we have b to the 2/3, b to the 4/9. We have c to the 2/5, c to the 9/10. Okay, normally we just add these together. But in order for us to add a fraction, we need to have the same denominator. So we're going to have to convert. So 2/3 and 4/9. Well, I could figure out what 2/3 are and convert that into ninths, right? Multiply by 3 over 3. We're multiplying it by 1. Right? So that's that multiplication property of 1 that we talked about in our first semester. So if we do that, we end up with b to the 6/9 plus 4/9, right? So 3 times 2 is 6, 3 times 3 is 9. So 6/9 plus 4/9. All right. Our c term, 2/5, but we need a denominator of tenths. Well, that's going to be multiplying by 2 over 2 to make it 10. So that's going to be 4 over 10 plus 9 over 10. And so our result here is going to be b to the 10/9. Okay. And it's going to be c to the 13/10. All right. I want you guys to try I through L on your own and then come back and check your work against mine. All right. So if I look at this first setup here, right? 3 to the third, okay, that's kind of weird. We're going to put that out in the front. And then we've got an x squared, x to the 11th. Well, 3 to the third, we haven't really done this. We kind of briefly did it at the beginning. 3 times 3 times 3 is going to give us 27. So that's the first bit. We have x to the second plus 11th, and that's going to give us 27x to the 13th power. All right. Letter I. Everything's being multiplied. There's nothing to be distributed from outside the multiplication, so we're going to just drop our parentheses here. And we are going to group everything together. Coefficients first, so the only coefficient we have is a 3. Then we've got an x to the third, y to the fourth, y to the third. Okay? No multiplication with our coefficients, so the 3 stays the same. Nothing happens with x to the third because there's only the one x term. And then we've got y to the fourth plus third. So when we do the math on it, we get 3 x to the third y to the 7th. All right, letter K. Group our coefficients first. 5 times 12. We have an x to the 4th. We have an x to the 10th. Now let's do the simplifications. So 5 times 12 gives me 60. Okay, and now we've got x to the 4th plus 10th, and that gives me 60 x to the 14th. And lastly, letter L. There are no coefficients, so we don't need to group them, but we have variables, 2 different ones. So we have x to the 4th, x to the 7th, y to the 4th. So same base, we add the exponents, 4 plus 7. And we've got y to the 4th. And 4 plus 7 is x to the 11th, y to the 4th. And that brings us to the end of Module 8.1. If you have any questions, please bring them to class tomorrow. Otherwise, I hope you have a great day.